So in yesterday's session we discussed about the open source things. Okay, so you already got the advantages of getting into open. You know, right? What is open source? Open source means the source code is distributed, not only the executable. You know the difference between the source code and the executable, right, Akhilesh? What is the difference between source code and executable? You're telling the opposite way. Yeah. So you got the advantage, right? Source code is something like it is intelligent. It can be changed. So if somebody distributes it, no need to put the same effort to develop the same source code. He can change and he can put whatever he wants on top of it, and he will reshare it, and he will build an executable and reshare it. So contribution is coming from everywhere. Okay. So that's why, and there is a philosophy also, philosophy of freedom of software development. It means you have freedom to do anything. You will get everything. The source code, you will get everything. And once the source code is distributed, if you are very clever, you can make much more contributions and you can build it better. So these are the advantages of open source things. Okay. So today I would like to discuss about yeah, the same thing I want to repeat for some time. You understood the Linux architecture, right? This is the general operating system architecture. Okay, I think you had a subject called operating system where you had studied all these things. The operating system is nothing but the collection of code. I am running this PPT and browser, WhatsApp, and all these things on Linux operating system. Okay, you cannot do the same thing on the microcontroller where you do Arduino or 8051 or 8056 or some microcontroller like that. Okay, this is the operating system. It is a collection of software. So here we discussed about the Linux architecture, how it is organized. There are different operating systems. Okay, Windows, Linux, FreeRTOS, and Musi Linux, and there are a lot of different operating systems available. So out of that, Linux has an architecture like this. Linux is organized like this. So the hardware, the kernel modules, the kernel, system libraries, and the user processes. So kernel is a piece of software which directly interacts with the hardware. It is at the bottommost layer. So ultimately what we have to do, we have to see, if you buy a car, it's like if you effectively use the wheels, accelerator, engine, and everything, then your system, you are effectively using the system. Similarly, if you effectively use the CPU, RAM, and IO devices, internet, network, and all, that is the ultimate goal of any user. Okay. So user interacts with the user, uses the hardware through the system libraries and the kernel. This is how the Linux is organized. The kernel and the kernel modules are written in C and assembly. System libraries are written in C and C++ and multiple languages. And applications, you know, right? Applications can be C, C++, or Java, or anything. These are applications are the highest level. Okay. So this is about Linux. See, don't imagine, don't feel strange about this architecture. Okay. Anyhow, it's a piece of code. So whatever the code you have written even in your lab exams or classes, they are just to prove some algorithm or to search something or to print something or something like that. But that is just an exercise. But ultimately, that will not come to your credit. You have to build a software something like this. Build a PowerPoint software. Develop a code. Okay, write a code to develop the PowerPoint software. Write the code and build the executable. Okay. In that case, the project will be very complex. The source code will be more. Okay. So what I'm trying to tell you is, anyhow, operating system is nothing but a collection of software like libraries, drivers, and applications. Okay. Let's come to today's topic. Okay. So today I am going to discuss some topics like let's see. Yeah. I'm going to discuss some things. Okay, do you know the difference between executable and source code? Right? Source code you can edit, modify, and when you compile it, it will become an executable. So finally, executable runs on the CPU. Executable is nothing but a series of zeros and ones, the machine instructions. It's a series of instructions finally which runs on the CPU. Okay, I will tell you about the compilation process in detail. Otherwise, you can also search. Okay, like C compilation model. You can see here. Yeah, this is a simple diagram. C source code. Preprocessor means there will be header files which will be included, and hash files. Okay, then the compiler converts the C code into assembly code. Then the assembler converts the assembly code into I think you have done 8051 and 8085 8086 labs, right? There you can see you will write the assembly code directly, right? Am I audible? You know the difference between the assembly code and the C code and the machine code, right? Prasha and Nandan. Yeah. Prasha, you are able to understand, right? If you are not able to understand, let me know, okay? You know the difference between the C source code, assembly code, and the machine code, right? No, you are telling in a reverse way. Machine code is the which directly runs on the machine, which is the CPU, which is nothing but zeros and ones. Okay. Assembly code is the code like move instruction and add instruction. They are instructions actually. I think you have seen in 8085 and 8086. You are from electronics or computer science background? Okay, okay. Then you should be knowing, okay, the compilation process, the C compilation process. The C source code is the C program, what printf and scanf and whatever you write there. Then you convert it to assembly, and then finally you'll get executable. Okay. So what is the need of linker here? Okay, I will explain you. Okay. So for example, if you write a hello world program, you will add a printf and then do hello world. Okay. So the printf is converted into a call assembly code. Call instruction means it calls a function. Okay, it jumps to some address where the function is defined. So linker at the time of compilation, so printf is called. Okay, printf is not in the helloworld.c. It is defined somewhere in the standard library. So it will resolve the addresses. It will resolve the printf with the correct address where it is located. So finally, it will be executed sequentially. Okay, this is the role of the linker. So, so in a C code, you will have all these steps like pre-processing, compilation, assembler, and linker, and finally the executable. Okay. So we came to know about the .c files, which is the C code. Okay, keep that in mind. That is our point of interest. And also the linker is also important because we are using some functions like printf, scanf, read, write, some other functions in the C code. So linker will resolve all those functions at the compilation time. It will put the address of the printf where it is defined. Okay. So finally the executable. So printf is defined in the standard library. So libraries also coming into picture. Libraries, executable, .c file, and the assembly code. So assembly code we don't worry at this point of time. Let us discuss about, these are very important actually. Libraries are very important in Linux because everything is built with the libraries only. The common piece of code will be used across multiple processes. I will tell you an example, okay, about the library. Consider you want to write a hello world program, okay? In main, so you will do printf. You are able to see the screen, right? Yeah, printf hello world. Okay, slash to move the next line. So integer return 0. Main is returning 0 because I am defining main as the main with the int as the return type, okay? So I am returning 0 here. So consider there is no printf available. Okay, printf doesn't exist. What you will do to print hello world? You have to access the output screen, then send characters, then send hello world to screen to print it. Okay, this is what you have to write to print the hello world code. Okay, consider this is you are printing hello world. Okay, now you have one more function called hello Europe. Okay, so there again you have to print hello Europe. So again you have to repeat the same steps. So instead of hello world you will send hello Europe. Okay, these statements are getting repeated, right, in each program. So these statements are getting repeated, so this can be avoided. Instead of that, I will have a function called printf. Okay, this function will do access the output screen and print the hello world. Okay, it will print the hello world, and I will call this function here. So instead of writing this instruction in every program, we are writing in one function and calling in every program. It means this piece of code is getting shared across multiple programs. So I can put this common code in some location. This is a common code, otherwise the space will get wasted. To save the space, I will put it in a common place and I will use this function all over here. So this common function came into picture. Okay, so this is a printf. I'm explaining with the simple examples. Okay, so what they did, consider this is printf.c, stdio.c. stdio.c has got the printf, and stdio.h has got the declaration. We need declaration and definition both, right? So what they will do, they will compile this and they will generate a library, object code. You know, right? Machine code. This is not exactly the machine code. One level below machine code. This is called as object file. Okay, stdio.o, and whenever I am compiling hello world program, I will link this object file. So this is called as a library. Okay, so these object files are kept in an archive, and they are linked at the runtime. So in case of Linux, printf is defined in libc. This is called a C library. C programming library, libc. Okay, libc.so. Okay, so you understood the library concept, right, all of you? Any doubts? Yeah, correct. Yeah, See, I'm just explaining you because Akhilesh and Nandan are very new to this field. They are in 7th semester, okay. So these dot files are generated. Finally, an archive is created. Yeah, archive is created. Archive means zip file, right? Zip file is nothing but the collection of files. So they will put all the object files in a zip file, and they will make it as a library. So archive is .a file. If this is a static library, if this is a dynamic library, it is called as libc.so. This is called as shared object. So you understood, right? You are able to follow Nandan and Akhilesh? Okay. Because I will start giving the tasks from next 2 days. Okay. You have to complete it. So if you don't follow, it will be difficult. Okay. I will share the video, recorded video content also. Okay, now so we understood what is a library. Okay, it's nothing but the collection of .o files. So let's go through the PPT. Okay, now again I would like to discuss one more topic. You know what is an executable, right? Executable. There are two types of executable. Okay, static executable and dynamic executable in Linux. Static exe and dynamic exe. Okay, static linking means static exe is created through static linking, and dynamic exe is created through dynamic linking. Okay, static linking means there are no external dependencies. Okay, there are no external dependencies, but in dynamic linking there will be dynamic dependencies. Okay, for example, that's what static linking means. Linking means, right, resolving the symbols. I'm using printf here. I'm going to resolve where it is, where the printf is, and I'm going to call it as linking. Okay, static linking means there will not be any external dependencies. There is at the runtime. Okay, when the program runs, when the exe runs, there are no external dependencies. That exe is just enough. Okay, but in case of dynamic linking, at the runtime there will be dependencies. Some libraries are required. Okay, static linking is also called as compile time linking. The symbols are resolved at the compile time. But in case of dynamic linking, the symbols are resolved dynamically at the runtime. Okay. So if you call, I will give you an example with the code. Okay. Hash include. This is my editor. Okay. This is how I code in Linux. You can use gedit, some text editor like this, and you can write the code and save. Otherwise, if you want to learn, you can learn this one also. This is very powerful. This is a simple code. Okay, it is just printing hello world. Okay. So I will tell you how to compile this code in Linux. Okay, in Linux, code will be compiled through the C codes will be compiled in terminal by using a compiler. The compiler is called as GCC compiler. So if you press GCC, this is called as a terminal. Okay, where we write where we compile and where we interact with the operating system. Okay, if you press GCC is the command. You know Windows commands, right? ipconfig, ping command, or how you execute the code in Windows. Similarly, yeah. Yeah, these are new projects actually. These people are new. That's why I'm explaining them. Okay. Yeah. If you type GCC, it says there are no input file. GCC is a command to run the compile the program. Okay, this is how to compile. GCC, then specify the output executable. Hello, then hello.c. Okay, so now there are two files. One is the output file hello and the source code hello.c. Learn the Linux commands. Okay, I will give you a command reference manual or a cheat sheet, a single page or 2-page command reference card. Go through those commands. Okay, in Linux commands are very important. These are some of the very basic commands. So ls is to list. Okay, ls is to list hello and hello.c. So these two files are there which are created. Okay, this is how I can run the code in Linux. Okay, /hello. Okay, so you can see hello world is printed. This exe printed the hello world. Okay, so now we just compiled. Now actually we were discussing about static executable and dynamic executable, right? So if you want to know about the file details, just type file command and give the file name. Okay, it gives the details about the file. It says it is dynamically linked. Okay, it means it uses runtime dependencies. Okay, let us try to compile statically. Okay, I will specify the output file name as static. So previously it was hello. This is hello static. Okay, hello.c. I will also pass an option called static. Okay, this is also compiled. So now let us list all of them. Okay, hello.c and hello_static. So now there are 3 files. The green color indicates it is an executable, and white color indicates they are other files. Okay, this is an executable. These two are executable, hello and hello statics. If we pass one more option called list with details with -l, it shows the size information and who created that. I will tell you all this information later. Okay, what is RWX, what is one, what is this is the username Chandra, and this is the size. Both are same C code. Okay, hello.c is same, but this dynamically linked executable, this file hello, is 16,696 bytes, but hello_statics is 871,896 bytes. Okay, this is bigger. Let's run the file command on this. Okay, see here you can say it is statically linked. Statically linked means it's a compile time linking. So linking means, you know, right, at the compile time this printf will get resolved, but dynamically means dynamic linking means at the runtime the symbols are resolved dynamically. So for example, here if you want to know the dependencies, there is a command called LDD. Okay, LDD, and give a file. Okay, this is a dynamically linked executable, LDD hello. So it is using all these libraries at the runtime. libc.so.6, Linux VDSO. These are the shared libraries which are used at the runtime. But when we run LDD to hello_static, it says it's not a dynamic executable. It means these libraries are getting loaded at the runtime when the executable runs. The dynamic linker resolves the symbols, and these object files, these object code are loaded at the runtime, but here they are already linked at the compile time. It means all these libraries, whatever they need to print the hello world or a basic code, is put it in the executable itself. so the size is more. But here they are put in a common place. Whoever they use these libraries, they will be loaded at the runtime. So there is a common shared code. This is a common shared code at the runtime. But here it is linked at the compile time. All these libraries are added at the compile time. So the size is more. You are able to understand, right? See, I am putting my 14 years of experience, okay, to make you guys understand. Okay, this level of explanation I don't think anybody will give you. Okay, you're able to understand, right? If you have any doubts, you can ask me right now. You want to see the libraries which are being used at the compile time, huh? See, normally by default libc will be linked at the compile time, okay? Libc, in case of here, uh, so you can say these are the very minimum dependencies, okay? These are commonly used in all the executable. This is LD linker, okay? Don't worry about all this explanation. I'm going to explain to Prash only. libc.so is the shared library. So similarly, by default, when compiler runs, libc.a will be added, okay? There will be one more library called libc.archive. That is a static library that will be added at the compile time by default. That will not be shown, okay? But if you want to include separate libraries, for example, there is a library you downloaded from the internet and you want to use its APIs and headers, and you want to you want to call them in your code, then you can specify like this, like -l, the path to the library, and then if it is liblogic, we will specify lib as L, and then logic, liblogic, L logic. So -l is to say link it, library path, and L logic. So we will come to know what are the libraries we are linking at the compile time. But static executable will not have any information about the libraries because there is no dependencies. There is no library dependencies. At the compile time, whatever we add, those libraries will be linked. You're able to follow, right? Yeah. We do, if you don't want to return, don't return 0. It's not a must. You know why you will return 0 in most of the functions, right? See, always returning a 0 indicates a successful return. Returning a minus value or a negative number indicates the function has failed. So this is a main function. We declared that it returns integer, and if we print that, it is fine for us, so it is successful execution. And to tell to the terminal which runs this program, this is the terminal which runs this program, and we are returning 0, and we are telling that we had a successful execution. No, sometimes operating system interprets as errors. Yeah. Anyhow, why it will come as a compile time error? It's a runtime, right? Return will happen at the runtime, right? Say we are returning integer. We can return any integer here. We can put 100. Return 100, return 1000, any integer. Okay, So let's come to the PPT. Okay. So you understood, right? Static executable. So all these object files are linked at the compile time itself. There will be single executable. There is no external dependencies. All these OBJs are linked at the compile time. Okay. When it comes to the shared, let me see, shared executable. There will be runtime library dependencies like libc libraries, and there are a lot of libraries, runtime library dependencies. I will tell you later. Okay, these are some of the basic key concepts that you have to remember. Otherwise, you will start using the memory skills to remember the commands and remember the process and do it. Don't follow that. Okay, try to understand what is happening. So similarly, the library. So all the shared library and the static library. It's nothing but the collection of code. Okay. They load at the runtime. It says saves runtime memory. Yeah, this is very important. It saves runtime memory. How? Okay. See, there are two executables I told, allow and allow static. Allow and allow static. Okay. When this code runs, it requires at least 16.696 bytes of memory at the runtime. Minimum requirement. Okay. But allow static's minimum requirement is 871 KB. So runtime memory is very less when we use shared libraries, because of piece of code is shared across multiple processes. But in case of static library, it will be more. Okay. So can we correlate with this diagram? So now we understood, right, what the system library is as collection of .o files. Kernel is nothing but collection of .ko files, kernel objects. This is object files. .o is object file, but kernel files are called as .ko, kernel object files. Anyhow, we are not going to cover .ko files. Okay, we will be discussing about from here to here. So any doubts about today's session? I would like to close the session. I want to continue with the compilation and the cross compilation and makefile building GDB and all in the next class. Okay. Any doubts, Akhilesh and Nandan? You are able to follow, right? Let me know if you don't follow. Okay. Okay, guys. I will send the recorded session. Okay. You can go through that once again.